Hello dear students, myself Dr. G.S. Bhopalkar, Department of Chemistry, Rajiv Gandhi Mahavidyalaya, Mudkhed. We are at the end of this topic at synthesis and uses of dyes. I have already posted the study material of this dyes, drug and dyes compounds. I have posted the study material on synthesis and uses of dyes by Google Classroom on dated 27 August 2020. Now, in this session, we will discuss about the synthesis and uses of dyes which are included in our syllabus. This is the syllabus of your BSc third year chemistry. We have to learn the synthesis and uses of dyes of alizarin, methyl orange, diamond black F, Congo red, orange second, and indigo. Means these six dyes we have to learn about their synthesis and uses. Now we will see one by one, that is Congo red. Okay, because Congo red has been included in our syllabus. Then what is Congo red? This Congo red is the member of diazo compounds. Means we have learned about the classification of dye which is based on the method of application, and to that there was the fifth class, that is developed a dye, which that is azo dye, diazo compound. Means this also it is belongs to that type. It is the synthesized by the coupling reaction of 1 mole of tetraazotized benzene with 2 molecule of naphthenic acid. What is the difference? Here tetraazotized means there are how many azotized? Tetra means 4. 4 nitrogens are there. Means tetraazotized benzene. There is a benzene structure in between the tetraazotized, and the reaction of with tetraazotized benzene with 2 molecule of naphthenic means 1 mole of tetraazotized benzene with 2 molecule of naphthenic. This reaction takes place to yield a Congo red as a dye. Now this is the structure of tetraazotized benzene. This benzene ring is attached to this benzene ring. That's why this is the structure of benzene. This position at there is a N2 means N double bond N, Cl means N2, diazo means there are 2 nitrogen atoms. From this side also there are 2 nitrogen atoms, means therefore the name of compound is tetraazotized benzene. And when the 1 mole of tetraazotized benzene is treated with 2 mole, this is 1 mole, this is second mole, means 2 moles of naphthenic acid. This is the structure of naphthalene ring. It has a SO3H functional group, that's why acidic, and there is a amino functional group. Therefore, there is a naphthenic acid. This is naphthenic acid means the 2 moles of naphthenic acid is reacts with 1 mole of tetraazotized benzene. There is a coupling reaction takes place in between this nitrogen and with the phenol ring, or sorry, naphthalene ring, and we get diazotized coupled product. Means whatever the N2 plus is there, plus sign is get removed after the coupling reactions. How? The nitrogen atom having lone pair of electrons, this lone pair of electrons are shared. 1 minute. This lone pair of electrons are conjugated with this bond, and therefore this bond is having gets shifted here. It becomes minus charge, and this minus charge means the anion will be attacked on the positive charge of diazotized nitrogens from the both sides, and there will be the n double bond n is formed, new bond n double bond n is formed, and this is the structure of Congo red, and it has a red color in alkaline medium. Okay, means the Congo red is prepared. Congo red has been synthesized from the two molecule of naphthenic acid with tetraazotized benzene. Okay, now if the Congo red is having red color in alkaline medium, and when we add acid medium, that is HCl, to the Congo red, at that time this H proton get abstracted by this nitrogen atom. It has a lone pair of electron from both sides. Therefore, the acid get protonated on this nitrogen atom. That's why these both the nitrogen atom become positive charge. Okay, and to stabilize this positive charge, whatever the double bond in between this nitrogen and this nitrogen, it is it is used for the stabilization of positive charge which is present on this nitrogen atom, because the driving force for the stabilization of positive charge on this nitrogen atom is coming from this amino functional group. Means it has a lone pair of electron which is conjugated with this n and carbon bond, then this single bond is conjugated with double bond, and then this single bond get converted into double bond, and the double bond get converted into single bond with the stabilization of positive charge on the both sides. Therefore, after addition of H plus an acid in the Congo red, it becomes protonated and it is stabilized by the resonating structure, and we get such type of diimino compounds, that is the n double bond and double bond n. Okay, and then this compound has a blue color in acid medium. Means the structure of Congo red in alkaline medium is in this form: n double bond n, n double bond n, and the structure of Congo red in acid medium is in the form of n single bond nh, n single bond nh, and it has blue color. Okay, this is about the synthesis of Congo red. What are the uses? It is used as a synthetic dye, which is used with the dye with cotton. Means it is used to dye with the cotton purpose. And the salt of this dye which dyes to the cotton very perfectly, and it has red color in alkaline medium as I have told that, and blue color in acid medium. Okay, this is about the synthesis and uses of Congo red. Okay, the next dye, that is alizarin, we have to learn the synthesis and uses of alizarin. This alizarin is also called as 1,2-dihydroxyanthophenol. This is one position, this is two position, 1,2-dihydroxy, and this is the structure of anthraquinone. Means this alizarin is synthesized by the condensation or the reaction of phthalic anhydride with catechol. This is called as catechol. Means 1,2-diol or 1,2-diphenol, means 1,2-diol is called as catechol. When the catechol is get condensed with phthalic anhydride in presence of sulfuric acid at 180 degrees Celsius to yield alizarin, and the name of compound is 1,2-dihydroxyanthraquinone. Okay, this is the structure of 1,2-dihydroxyanthraquinone, and this is the synthesis. Right now, it is used as a modern dye. You have well known about what is the role of modern dye. because we have already learned in the classification of dye, and it is used to manufacture the printing ink. Whatever we are ink using for the printing purpose, we can manufacture, or it can be manufactured from the industry for the preparation of printing ink, and it is used to dye for textile fabrics. Whatever the textile fabrics, they get dyed with by using the alizarin as a dye. Okay, this is the structure of alizarin. Now, next dye for your syllabus is indigo dye. This is indigo dye. Okay. Now, what is the indigo dye? This is the structure of indigo dye. Okay. Now, this is as acetylene chloride and indoxyl, means the basic or the main compound from which we can prepare indigo dye is acetylene chloride. Means it is natural dye, and when it is derived from indigofera group of plant. Why this is called as natural dye? Because it can be derived or collected from the indigofera group of plants, and it always present in a plant as a beta glucoside indoxyl. It is always present in the form of beta glucoside. Right? Now, how it is prepared? It is prepared by the reduction of acetylene chloride. This is the structure of acetylene chloride. C double bond O Cl benzene 5-member ring attached. That is acetylene chloride. When this acetylene chloride is reduced by using zinc dust in acetic acid, there is a reduction reaction takes place, and it gets converted into indoxine. This is the name of compound, that is endoxyl. Cl and double bond is get here reduced. Okay. Now again this endoxyl on oxidation by using oxidizing agents, this endoxyl get converted into indigo dye. This is the structure of indigo dye. Okay. Means two rings get coupled with each other because of the oxidation. Right now this is the structure of indigo dye, and it is used as a natural dye, because I have already told that it is used as a natural dye, and it has solid dark blue color. Okay, it has what type of color? Solid dark blue color. This is about the synthesis of indigo dye. Right? Means we have learned how many dye? 3 dyes. Means first one we have learned the Congo red. Okay, this is the structure of Congo red. This is the structure of Congo red. Then we have learned alizarin. Okay, and next at last we have learned the indigo dye. Okay, now next dye we have to be learned, that is orange second, and this orange second is also called as beta naphthol orange. This is the another name of the orange second dye. Now how it is prepared? This is the structure of orange second dye, and this reaction is carried out because of the coupling reaction in between the beta naphthol. This is beta naphthol. 2-naphthol means beta naphthol with diazotized sulfanilic acid, because N2 positive charge and Cl minus means diazotized sulfanilic acid. When the diazotized sulfanilic acid is get coupled with 2-naphthol, at that time in the basic medium there is a coupling reaction is takes place at this position, and that is one positions, and we get such a diazotized compound, and that compound name of the compound is called as orange second. Means it is prepared from the starting compound diazotized sulfonilic acid. Okay, now this diazotized sulfonylic acid treated with 2-naphthalene gives orange second, and this orange second is used as a what purpose? As a dye, and it is also used to dyeing with wool, cotton, fibers and silk. Okay, and it is also used to dye the paper and leather also. Therefore, orange second is used as a dye. It is a very simple dye by the coupling reaction of naphthol, 2-naphthol with diazotized sulfonylic acid in basic medium. Okay, and this is the structure. Means we have to make a practice by drawing all these structures for each and every synthesis of dye. Now, next one is the diamond black F dye. This is diamond black F dye, and this diamond black F dye is used as a what type of dye? Modern dye. You have well known about the acid dye, basic dye, then modern dye, direct dye, vat dye, azo dye. All these are the class of dye. Means this it is used as a diamond black F is used as a modern dye, and it is prepared by the coupling reaction of diazotized 5-amino salicylic acid with 1-naphthylamine. Means there will be the coupling reaction is takes place in between the diazotized 5-amino salicylic acid. This is diazotized. N2Cl means diazotized. 5-amino means at from this COONA. This is 1, 2, 3, 4, 5. There is a fifth position. There is a diazotized amino functional group is there, and the COONA and OH is become the parent name of salicylic acid when they are attached with the benzene ring. Therefore, the name of compound is diazotized salicylic acid, and when this diazotized salicylic acid is for diazotized 5-amino salicylic acid is treated with 1-naphthyl at one position. There is a amino functional group that is 1-naphthylamine. We get amino azo diester. Means there will be the coupling reaction which takes place in between from the driving force from this nitrogen atom is here, and which activate to this point of 1-naphthylamine, and there will be the coupling which takes place in between the from fourth position of 1-naphthylamine to the diazotized functional group, and we get such type of amino azo diester. And this amino azo diester is having a free NH2 functional group. Therefore, we can carry out its diazotization reaction, again further diazotization reaction by using sodium nitrite and HCl. And these reagent or reagents are used for the diazotization purpose, and we get again this NH2 get converted into N2Cl. Means again we get diazotized product, and when this diazotized amino azo diester is again treated with 1-naphthol 5-sulfonic acid, this is another moiety. Before that we have used 1-naphthol amine. Now in the second step we are using 1-naphthol 5-sulfonic acid. Again there is a coupling reaction which takes place at the second position of this phenol, because this is the active position, and there will be the coupling reaction which takes place in between these diazo compound, diazo structure with the second active position of this 1-naphthol 5-sulfonic acid. This is 1 and this is 2 positions, and there is a diazo bond is formed in between N double bond N. Means this is the total structure of diamond black F that contain 2 azo or diazo functional groups. Okay, one is having benzene rings or salicylic acid, another is having ethanic acids, and this is the structure of diamond black F. Okay, now This diamond black F dye is used as a modern dye to develop the dye of fabrics cottons, and it is also used to dye with wool, silk and cotton. Okay, means in this way we have learned the synthesis and uses of diamond black F, orange second, indigo dye, then alizarin, Congo red and methyl orange. All these are the dye which have been used as a dye and that can be synthesized in the industry. Apart from the six dye, there are some examples. There are another dyes are given in this study material, that is phenolphthalein. Okay, methyl orange. This is for your extra study for your further assignment. Okay, now today we will be stop here in this session. We have learned the synthesis and uses of dye right now, and in this way we have finished the chapter, that is synthesis of and uses of dye. Means we have also completed this chapter, that is synthesis and uses of drug and dyes. Means we have finished the drug and dye chapter. Okay, in the next period, our next session, we will discuss on the next new topic. Thank you.